Hello everyone, welcome to my data structure series. Today we are going to talk about stack as an ADT. We have already seen linear and non-linear data structures. I request you to look into my previous videos and then come to this video. Right, so let us see the stack ADT. The stack ADT, we focus only on the data and operations, not on the implementation part. What is a stack? Stack is where the items are arranged one after the other. The item that last gets into the stack will be first out. Other words, I call this to be last in, first out, or LIFO. Fine. Now, what are the operations of a stack? There are three major operations and two optional operations that you should definitely know. One is push, which inserts an element into the stack, pop, which removes an element from the stack, peek, which is used to display the current top element of the stack, is empty, which checks for whether the stack is empty, is full, which checks whether the stack is full. Again, it depends upon the requirements of the user while you are implementing and while you design the system. Fine. So you should understand that writing code is simply not an ADT. Talking about arrays, linked list, how to implement this stack is not ADT. Only operations are ADTs. Fine. Let us look into the operations in detail. Number one is push of X. As I told you, this will insert an element into the stack, right? So a clear ADT style definition is that push of X adds element X to the top of the stack. So now you have a new terminology called top, which you can imagine as a pointer which points to the current element in the stack. So the topmost element will be the element that is inserted at the last. So top will be a pointer. Fine. Number two is pop, right? Pop removes an element, removes and returns the topmost element of the stack. Right. Number three is peek. The purpose is to only access an element. So this peek will return the topmost element without removing it. Okay. In other words, you need to display the elements of the stack, the topmost element of the stack. You can use this function. The next one is empty. So the purpose is to only check the status of the stack. So this is going to return true if stack has no elements. Maybe you can check initially if the stack is empty and then you can start pushing elements into the stack. The last one is full, which is again, as I said, optional. It depends upon the implementation. The purpose is to check the capacity of the stack. It returns true if stack cannot accept more elements. Done. So these operations define the behavior of the stack, but they don't let us know whether we use arrays or linked list for implementing stack. Stack can be implemented using arrays. Stack can be implemented using linked list. But see, number 1, 2, 3, 4, and 5 operations defines only the behavior of the stack. So nowhere the implementation details are being thrown to the user. That is ADTs. Done. So if suppose you have still more few doubts on these ADT operations of stack, let us try to visualize things. First one, let us try to insert a data element into the stack. So push operation. So this is my stack initially, right? I am trying to push 10. So afterwards, the stack look like this. Next, I assume I try to push 20, right? 20 is being pushed at the top of the stack. Look at the top pointer. Top was pointing to 10. Now top is pointing to 20. It is getting incremented by 1, right? It is pointing to 20. Push always adds element at the top. Now let us try to delete an element using pop operation. So this is the current status of the stack. after which I can only remove 20. I cannot remove 10 directly. This is LIFO, last in will be first out. So after one pop operation, the top of the stack again points to 10, right? So to just view the top of the stack, you can use the peek. Peek only looks, it will not remove. Is empty will return true if there are no elements, means the stack is empty, and is full returns true if suppose the stack is full and when there are no space left. So I assume here that the stack can hold only 3 elements and the fourth element cannot be filled. If that is the case assumed, then my is full is going to return true. Fine. So stack ADT, the important operations are push, pop, peek, is empty, and is full. Push adds an element to the top of the stack. Pop removes and returns the topmost element from the stack. Peek will return the top element without removing it. Is empty is going to check whether the stack is empty, and is full is going to check whether the stack is full. So these are the 5 important operations of a stack. So hope you have understood what is stack ADT. So this ADT defines what operations are allowed. How they are implemented is not a part of ADT. What is an ADT? How is the data structure point of view? So please remember, stack is last in first out, or LIFO. LIFO means last in first out. Any doubts, post it in the comment section. I'll be happy to answer your doubts. Thank you. Happy learning. Stay connected.